Hey y'all, this is section 3.4.3, solving quadratic equations by factoring with some special formulas. I hope you like foiling. We're going to do so much foiling that you're going to be like, wait, Berg, there's a faster way. And I hope you find it before we get to it, because there's some patterns I want you to see. And the patterns we're going to generalize into some formulas. But the way we get those formulas is by foiling, and we're going to do a lot of it. There's so much of it that, in fact, the table is going to be this entire first row is going to be F first. The entire second row is going to be O outside. I is inside here, L, and then the sum is going to be down here, the very last row. So let's start with x plus 3x and x minus 3. X plus 3 and x minus 3. We get the first term is x squared. The outside term is minus 3x. The inside term, 3 times x is 3x, and the last term is 3 times negative 3, which is negative 9. When you add them all up, the middle two terms cancel, and you just have the first and the last, and you get x squared minus 9. Whew, okay. Let's do something like that again. 2x times 2x is 4x squared. 2x times 4 is 8x. Minus 4 times 2x is negative 8x. And then minus 4 times 4 is negative 16. When you add them all up, the middle two terms again cancel. You get 4x squared minus 16. Let's do something a little tricky. We're gonna reverse what we normally see with a 1 plus 3x and 1 minus 3x. So far, it's been like they've been conjugate pairs. You get x plus 3 and you get x minus 3. You get 2x minus 4, 2x plus 4. It's just plus and minus that are the difference. It's the same thing repeated. 1 plus 3x, well, okay, so the first terms is 1 times 1 is 1. And then 1 times minus 3x is minus 3x. And then the inside terms, 3x times 1 is 3x. And 3x times minus 3x is negative 9x squared. Lo and behold, the two middle terms, dun, 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 they cancel. So we don't have to write them. It's just going to be 1 minus 9x squared. Interesting. Does it fit the pattern that we've seen so far? Yes, 17 minus and then 17 plus, and then x. So first term is 289. The inside term is positive 17x, and the inside term is negative 17x. They're going to cancel too. Whew. The last term is minus x squared, so when you add them all up, you get 289 minus x squared. If you FOIL, just this is the generalized version. There's no numbers anywhere. It's always just going to be an a plus b and an a minus b. And if you FOIL them, then you get the first term is a squared, the middle term, the outside term is negative ab, the inside term is positive ab, just writing them in alphabetical order. And then, like, I'm not going to write ba because it's hard to compare. I think if you write them in alphabetical order, like A, B, then you see this negative AB and this positive AB, they cancel, they eliminate, and so when you add them all up, you just have A squared minus B squared. So, I think that you see the pattern now at this point. We don't even have to do the foiling. If you see that there's the pattern R plus 13 and R minus 13, you can just jump straight to R squared minus 169, knowing that those middle two terms are going to cancel. And that's what we're doing. We're going to generalize that. We're going to call this formula. When factoring a difference of squares, that's like, so here, sorry, let me just say it like this. When you have this, a plus b and a minus b, and you're foiling it, you can go here. But also, this is actually more important and shows up more frequently going in the reverse direction. So if you had an x squared minus 9 and you wanted to factor it, you can remember this pattern and go backwards to x plus 3x minus 3. If you had 4x squared minus 16, you could go backwards to 2x minus 4, 2x plus 4. Because you recognize this is a difference of squares. Here's a square, this is perfect square is 4x squared, here's a 16. And you can go back to this. 1 minus 9x squared. I recognize that 1 is a perfect square, and 9x squared is also squared, and there's subtraction in the middle. So you can factor it and go this way. 289 minus x squared. Both of these are perfect squares. The square root of 289 is 17. The square root of x squared is x. So it's going to be 17 minus x, 17 plus x. Order doesn't matter. Excuse me. All right, so generally, a squared minus b squared, if you have the difference of squares, you can say that they get factored into a plus b and a minus b. And that's exactly what the formula states. If you have a difference of squares, a squared minus b squared, you can factor it into a plus b and a minus b. So what does that look like here? What that looks like is x squared minus 100. Using the formula, I can name x is the a value is x. Like here's the pattern: a squared minus b squared. We have to fit our equation into this pattern. A equals x, b equals 10, and then therefore we could say it'd just be x plus 10, x minus 10 equals 0. Solve it, you get x equals plus or minus 10. Now I know you could add 100 to both sides as a first step here, and then take the square root of both sides and get the same answer. But we are developing a skill that's going to be used in a more complicated way later. Here. Oh, it looks like this is a difference of squares too. I know x squared is a perfect square, and 169 is going to be 13 times itself. So in this, if you're going to use this formula, then a equals x, and b would equal 13, and then you could just write x plus 13 and x minus 13. And those are going to be the two solutions. Here, x squared equals 64. Now I know you could just take the square root of both sides and get x equals plus or minus 8, but I'm just trying to show you how the pattern works. You have to create difference of squares, and then you get the square root of x squared is x, the square root of 64 is 8, and you can see it's a difference of squares. You write x plus 8, x minus 8. You could even FOIL it if you wanted to and get back to the original to check. But using your Algebra 1 skills, boom, that's what you'd get, and the answer is x equals plus or minus 8, which you already kind of knew because you could just take the square root of both sides over here. All right, let's subtract 289 from both sides, and we get 4x squared minus 289. Wait a minute, this is a difference of squares. Subtraction, square, square. So so the square root of 4x squared is 2x. And what number times itself is 289? It's 17. A is 2x, b is 17. So you write it twice. 2x plus 17, 2x minus 17 equals 0. And so then you get 2x plus 17 equals 0, or 2x minus 17 equals 0. X is equal to plus or minus 17 halves. Again, I know this is not the fastest way of solving these equations, but I'm trying to show you how the pattern works so we can use it in more complicated ways. What if we flipped the sign? What if it weren't x squared plus 100 equals 0? What if it were minus? Well, I'm so glad we developed our mathematical skills to be able to incorporate square roots of negative numbers, because we're going to take a square root of a negative number right here. X squared minus, and then what I'm doing is I'm really forcing subtraction. This pattern really here requires a difference of squares. It requires subtraction. It's not going to work if it's a squared plus b squared, which we see right here. There's no pattern for that. You can't factor it. But if you force the subtraction by changing this to minus a negative 100, you can take the square root of negative 100. We know what that is. That's 10i, because we spent all that time figuring out what I is. So you could say x plus 10i and x minus 10i. Algebra 1 skills brings us down to x equals plus or minus 10i. Here we get plus 169. There is no pattern for a squared plus b squared, but there is a pattern for a squared minus b squared. You can force the subtraction and get negative 169. Once it's negative 169, the square root of negative 169, maybe 3 weeks ago we weren't able to do this, but now we can take the square root of negative 169. We know that is 13i. And so we write x. If a is x and b is 13i, then it's a plus b and a minus b, or x plus 13i and x minus 13i. Algebra 1 skills, x equals plus or minus 13i. Here, x squared plus 64 is equal to 0. You get x squared minus a negative 64. Square root of negative 64, that's going to be 8i, because you're taking the square root of a negative number. So if x equals a and b equals 8i, then we get x plus 8i and x minus 8i equals 0. So again, Algebra 1 skills leads us to the solutions are x equal to plus or minus 8i. Flip the sign. We're going to subtract negative 289 from both sides, so we get 4x squared minus a negative 289. It's the same thing. It's very similar. The square root of negative 289, you can't take that without an imaginary number. And I'm so glad we forced the subtraction because it's here. Now we can have a squared minus b squared, where b is 17i and a is 2x. That's because 2x times itself is 4x squared. So then we have a plus b, a minus b, or 2x plus 17i and 2x minus 17i equals 0. Split them up, solve them, you get x is equal to plus or minus 17 over 2i. We're going to do another formula right here. We're going to do a whole bunch more foiling as well. The first row is going to be F. The second row is going to be O, I, and L. And it's going to be the same thing. We're going to do so much foiling that eventually you'll see a pattern. And I hope you do see the pattern before we get to it. I think the savvy student will. But before we do that, audio check. What's my favorite tea? I'm going to show you right here. My favorite tea is Bengal Spice. Ooh, tastes like chai tea, except in tea form. It's just really delicious. Bengal Spice. Check it out. Get some. So here, x squared plus 3 squared. That's really the same thing as x plus 3 times x plus 3. It's just the same thing multiplied by itself. So if you're going to FOIL it out, you get x squared. The outside and the inside terms are the same. You get 3x squared when you multiply. What is going on? All right, I had to fix that. When you multiply the outside terms, you get 3x. When you multiply the inside terms, you get 3x. They're not going to cancel at this point. They're going to be identical. And the last terms are 9. 3 times 3 is 9. So when you add them up, the sum is going to be x squared plus 6x minus 9. Let's take a look. 2x minus 4 is squared is going to be 2x minus 4 times itself. The first term is 4x squared. Inside and outside terms are both going to be negative 8x. Copies of each other. That's interesting. The last term is 16. So when you add them all up, you get 4x squared minus not 8x, but 16x. You got to multiply basically negative 8x times 2 minus 16. Oh, this is a minus here. No, it's positive. Oh, this is, yikes. This is the one that's positive. Right, because negative 4 times minus 4 times minus 4 is positive 16, and so we're going to be positive 16 there. All right. Next one, 1 plus 3x squared. That's going to be 1 plus 3x times 1 plus 3x. The first term is 1. The inside and the outside terms are both going to be 3x, and the last term is 9x squared. I'm going to write it as 9x squared plus 6x plus 1 because I just like writing the quadratic terms first, descending order. Like the x squared term, the quadratic x squared term, the linear x term, and the constant number. The inside and the outside terms happen to just be the same, so it's going to be 3x times 2, which is 6x. And so when we get a plus b squared, that's really just a plus b times a plus b. The first term is a squared, inside term is ab, and the outside term is also ab, and so we get b squared as the last term. So ab and ab, there's two of them. So we're going to write a squared plus 2ab plus b squared. I wonder what happens if we do a minus b squared. So we get a minus b times a minus b. We get a squared here, and then the outside term is going to be negative ab, and the inside term is also going to be negative ab. So these are still identical. The last term, minus b times minus b, is going to be positive b squared. So this becomes a squared minus 2ab plus b squared. I think we can cut to the chase here at this point. We've done enough of these to see the pattern. It's going to be the first term is going to be r squared. The last term is going to give 13 plus 13 times 13 is 169. And then we do r times 13, which is 13r, but you got to double it because there's two of the terms, the outside and the inside. So 13r doubled is 26x and 26r. 26r. Great. So that's that. So perfect. So when you're factoring, if you see x squared plus 6x, and this should be, why did I do that? All right, plus, everyone makes mistakes. We just got to make mistakes and learn. That's all. Okay, so this is x squared plus 6x plus 9 here. The pattern you've got to recognize is you got to choose an a and a b value so that a equals, for example, here a would equal x and b would equal 3, and the middle term is double the product. When factoring a perfect squared trinomial, use the formulas a squared plus 2ab plus b squared. We found those, right? They're right here. And that equals a plus b squared. And here, this would be a minus b squared with a subtraction here. You've got to choose a and b wisely so that when you take the this middle term, it's going to all it's going to be the a times b doubled. So solve this using what we got. Let's see. Here, x squared plus 12x plus 36. Now, if you wanted to, you could split the middle. You could say, oh, what two terms, let's see, what's a factor pair of 36 that adds up to 12? And you say, oh, it's 6 and 6. But we're developing some skills that are going to be used a bit later, so let's make sure we can also use the formulas. A really amazing honors student is able to solve the same problem multiple ways and knows why and knows how. Because sometimes it's going to be advantageous to split the middle, and sometimes it's going to be advantageous to use the formula. So let's use the formula here because we're learning how to use it. So even though we've been doing so much practice with split the middle, let's develop another way so that we can use it when it's actually advantageous to use that particular formula. So here it is: x squared plus 12x plus 36 equals 0. Let's choose a to be x, because that would be right here, x squared is a squared. And let's choose 36, okay, b equals 6. So we got that right there. And we notice that we're allowed to use this formula because a times b is x times 6, that's 6x. When you double it, you get 12x. Oh, good. So the formula, it's in this pattern, a squared plus 2ab plus b squared. So we can say that it goes right down to x plus 6 squared is equal to 0. And so therefore, when you take the square root of both sides, x plus 6 should be equal to 0, and x is equal to negative 6. All right. Here, we can't really go anywhere in the world of quadratics if it's not equal to 0. So let's set things equal to 0. And then you can see here, after subtracting 10x from both sides, we can see that a is going to be equal to x, and then b is equal to negative 5. And you could also say that b is equal to just 5, because 5 times 5 is 25. And in order to produce the negative here, we're going to have to use the negative version of this formula. We found it right over here. A squared minus 2ab plus b squared is going to be a minus b. So actually, I think I'm going to declare that b is going to be equal to positive 5. I just think that it's a little simpler that way. A equals x, because x squared, b equals 5, that's fine. And now, knowing that there's subtraction here, 5 times x is 5x, doubled it is 10x, and in order to produce the subtraction, I use the formula that has subtraction, x minus 5 squared. Now, if you FOILed that out, you'd be able to get back to the original, but the whole point is to factor it, and you get x minus 5, and then you can figure out what's underneath that dot right there. All right, this is it's kind of we're going to have a little amount of preliminary work to do here, because really what I want in order to solve this well, I'm expecting it all to equal 0, and I'm also expecting it to kind of be in descending, exponent form. You put the highest exponent first, and then on downward to just the constant. So I'm going to rearrange things a little bit. I'm subtracting 18 h from both sides. This is actually going to be a negative. Wow, I got a lot of fixing to do on this one. This is going to be minus 18. So then this is going to be minus. And this is going to be minus. I should have paused the video. And this is going to be plus. Thanks, y'all. All right, so we're subtracting 18h from both sides, you get that, and then h squared is, a is h and b is 9. I do that because you can take the square root of 81. You can take the square root of that h squared, and you get a is equal to h and b is equal to 9. But in order to make it all work, we've got to make sure that we get a minus here. So h times 9 is 9h, and double it is 18h. The formula is going to work, but we just need to make sure we use subtraction. H minus 9 is squared. Anyway, if you were to FOIL this out, you get back to the original, which is a good check. But I'm going towards that solution, which is h is equal to 9. Next, we got to solve set it equal to 0. So preliminary work, we got to add 1 to both sides. When we do that, we can see we get perfect square trinomial format. That's because we take the square root of this side and take the square root of this term and take the square root of this term. You get a is equal to 3x and b equals 1. Multiply them together, you get 3x. Double it, you get 6x. To check the middle term is great. There it is. So then we have 3x plus 1 squared is equal to 0. When you take the square root of both sides, you get 3x plus 1, or in solving it, you get x equals negative 1/3. Let's see, I wonder if this is in perfect square trinomial format. Let's take the square root of this term, you get 4x squared. What times itself is 4x squared? It's going to be a lot of work to fix. But boom, there it is, it's fixed. Whew, I was asleep when I wrote this one. All right, so we get 2x and 7. When you multiply them together, you get 14x. Double it, you get 28x. So there, we are in perfect square trinomial format. We can use the formula. This is a plus, oh man, still asleep. We get minus 7 there, and minus 7 here. And this is, the answer is going to be positive 7 halves. There it is. All right, let's keep going. So which method would you use to factor and solve each equation? We got a whole bunch of possibilities. For here, you always have to do the preliminary work of setting all equal to 0 and factoring out the greatest common factor. But at this point, I'm going to use split the middle because it doesn't follow any formats. Here, I'm going to split the middle again. This doesn't look like difference of squares or perfect square of trinomials. I'll split the middle for that one. I'll use difference of squares here because it's I can write it as a squared minus b squared format. Here, I'm going to use the greatest common factor because you can factor out a 5x from both of these terms. And here it looks like a perfect square trinomial. So because when I set it equal to 0, this is a perfect square, and then this is the middle term, and this is another perfect square. I'm not going to do a whole lot with this because it's already a huge, super long video. But you could say convert each function from standard form to factored form by factoring. So here, sometimes it's just super convenient to see functions not in this form, but in this form. But it's a perfect square trinomial, so you can factor it and make it look like this. Here, the greatest common factor would be 2. Factor it out, and then you can use the formula again. A squared plus 2ab plus b squared would be a is x and b is 5. Here, factor out a negative 3, and you get something you can factor as well. I've been talking long enough. Thanks for sticking with me, and I can't wait to see you in class, and we'll work on this and chew on it even more. Keep up the good work, and I'll see you in class.